Hey class, Mr. Debski here. We're going to go over some of the homework assignments from yesterday. We're going to do some general review from chapters 14 and 15, and we are going to basically get you ready for that test of chapters 14 and 15. So without further ado, let's put me down in the lower corner there. And let's take a look at the answers from, actually, let's put me back up here. Let's take a look at the answers from 1 through 6, chapter 14. Now, just check your answers on these. If you sent them to me through Google Classroom, I will, sometime in the next 24-hour period, after you submit them, take a look at them and return them to you. I'm not going to mark them up, obviously, because that's a little bit hard to do on the computer. So here's the answers. If you've already submitted those, good. If you haven't submitted those, then why don't you stop right now, do the homework assignment like you're supposed to, and then submit them. And then after you do that, come back here, and we'll check the answers. So we've got number 1, acids are defined as substances that produce hydronium ions. And that is letter A. You're going to see that a lot on the test. That's a key word in this chapter, hydronium. If you have a choice between hydrogen and hydronium, choose hydronium. That's H3O with the +1 oxidation. I'm sorry for shaking this. It's just not on a level surface. I've got my book here for the questions. Number 2, a triprotic acid is one that has 3 acidic hydrogen atoms. Remember, we can have monoprotic, diprotic, or triprotic, and this 2 and 3 hydrogen ones are also called polyprotic. So triprotic means 3 hydrogens. The example on your sheet that I gave you was H3PO4, which is phosphoric acid from the phosphate ion. Number 3, you don't need to know. So this is on page 513. Number 3, if you want the answer, it's letter C, and you can write out the equation for your homework assignment, but I won't require you to do that. We're going to spend a lot of time on weak acids and strong bases and weak acids. Number 4, bases are defined as substances that produce hydroxide ions, letter 3. Okay, that's the most basic definition of a base. Got you right there. Number 5, which of the following is a strong acid? Look at your list if you need to. But again, you should know on the strong acid side we had hydrofluoric, hydrochloric, hydrobromic, hydroiodic, and we also had hydrochloric and sulfuric. And so on the list here, acids, HCl, letter D. Number 6, which of the following compounds is a basic anhydride? Go back and look at your notes. Make sure you know the difference between a basic anhydride and an acid anhydride. Acid anhydrides make acids, and so those are made out of metal oxides reacting with water. Basic anhydrides are non-metal oxides like nitrogen oxide, carbon monoxide, carbon dioxide, sulfur dioxide. Those are nonmetals that react with water and form acids. The next set of questions on that homework assignment was on page 551. So let's take a look at those 6 answers. 1, 2, 3, 4, 5, 6. Again, check your answers and use these 10 questions. 11 questions to study for the test, because some of these questions are almost word for word on the test. What is the symbol for a hydronium ion? Better know this one, H3O with a +1. Use the chemical equation to answer question 2 and 3. So the equation is, let me pull this up here just so we can look at it together. I'm going to go down in the corner here. The equation looks like this. It's Mg Okay, well, evidently I still have some issues. M, that doesn't look very good. Still working on technology here, guys. Okay, M, G, O, H. Oh, that's horrible. Let me rearrange things here. If you could see the mess in this office, I mean, you'd probably see a mess already all over my back shoulder. Too many computers and iPads and phones and printers. In this office, I have 2 printers, a 3D printer, my 6 iPhones, my 2 computer screens, the 37-inch and the 23-inch, this laptop, that iPad, 3 sets of speakers, the Wi-Fi system, the internet input for the house. It's kind of crazy. But that's okay. This is my domain. That's not what we need. Hang on a second here, guys. Let's erase this here. Let's see if I can get this back. Okay, let's try Mg. There we go. OH2 reacts with hydrochloric acid to produce magnesium chloride, MgCl2, and water. Okay, so this is the reaction. There's several questions about it. Number 1, which of the compounds in the equation is considered a base? So you look at the first one, magnesium hydroxide, MgOH2. You see the hydrogens, the hydroxides here. That is our clue. That is a base. This is definitely not. The hydrogens there on the hydrochloric acid, HCl, are going to make it an acid. This, MgCl2, is not. And this, obviously, is water. So if we had to label this, and you will see a question like this on the test, then this would obviously be base plus acid produces salt and water, just like we talked about yesterday or whenever you watched the video for the first day's review. Number 2, or number 3, which of the compounds is a salt? There we go. MgCl2. Number 4, which ions are excluded from a net ionic equation? Now, we did this on the first lesson in this week, so you can go back through and you'll see me explain about how to show a complete ionic equation and a net ionic equation, but the spectator ions, letter D, are the ones that are going to be excluded, and that's going to be the magnesium and the chloride. Okay? But the answer to number 4 is spectator ions. And again, we could do this. We could write Mg plus OH, 2 of them, produces 2 H's plus 2 Cl minuses, produces Mg plus 2, sorry, getting sloppy, plus, the whole thing's sloppy. My handwriting will get better as I do more of this writing on the screen. 2 Cl minuses plus 2 waters. Okay, so these are spectator ions. Let me switch color here again, or let's pick a highlighter. Ooh, that's cool. Ooh, nice. So we're going to highlight the spectator ions. Here is 2 chlorines. Here's 2 chlorines. See? So they don't do anything. They're spectating. They're just watching. And here is magnesium plus 2, and here is magnesium plus 2. They're spectating, they're just watching. Okay, so basically we could cancel them out on both sides of this reaction, and what's left would be a net ionic reaction. They don't ask us to do it here, but we would write that as such. Okay, and it doesn't matter what order these are in, so I go 2 H pluses plus 2 OHs produces 2 H2Os. Or and we can get rid of all the 2's and write H plus and OH minus produce H2O. That, my friends, is the net ionic reaction, or net ionic equation. This one here, you don't see where I'm pointing. This one's the net. This one's the complete ionic equation, and that is an acid-base neutralization reaction again. Number 5, which of the following is true about a solution with a pH lower than 7? It's an acid. Now, we don't know if it's a strong acid, so I can't say letter A. It might be strong, it might be weak. So I can't say A for sure. B, the quantity of hydronium ions is greater than the quantity of hydroxides. Absolutely true. And that is, again, definition of the pH scale. So go back and watch the notes from that from yesterday. Number 6, in the equation, HBr is what? It's a strong acid. We know that because I had you memorize it. Look at your chart. You need to know those formulas. HBr, hydrobromic acid, is a strong acid. Okay, so it's 1 through 6 on page 513 and on page 551. The other thing I want to go through today is, I don't know if you saw it or not, is the answers for close this. I'm getting the hang of this. Okay. This form right here is in Google Documents, not Google Documents. It's in my Google Documents, but it's in Google Classroom. And your homework tonight, or whenever it is, and I can't keep track of what order these are in, but one of your homework assignments for this week is to fill this out and turn it in as a homework assignment. Now, let's be real here. If I give you the answers to this right now, and you fill it in as I give you the answers, it's not going to help you guys. I want you to use your notes, to use your brain, and to use your textbook to fill in that sheet and submit it to me as a homework assignment. When you make your brain work, it gets stronger and you will be better prepared for the test. Now, I can't see you at your house. I can't see what you're doing. I can't police you. Okay? If we were sitting in the classroom, I'd give this to you and say, take it home, bring it back tomorrow, and we'd go over the answers tomorrow. But I'm not going to make a separate video just to go over the answers to this. So if you're smart and you want to do your best on this test, stop this video right now. Go to Google Classroom, open up this document, spend half an hour filling it out, submit it to Google Classroom, and then come back here and see if you got them right. I'll return it to you, but again, I'm not sure I have a way in Google Classroom to grade these things 100%. I'm going to give them a quick look. I'm going to see how many you got right or wrong. I'm going to give you a grade up to 20 points for it. But I really just don't know how that's all going to work out. Okay? So let's go through this, since this is our review for the test. And this is a study guide. These are actual questions I've taken from previous tests in previous years and turned into a study guide. Don't assume this is the only thing. You need to also study your acids and bases, strong and weak. You need to study all those things on the acid and base columns. You need to go through your notes. Okay, but these are some things, again, that are great to discuss so we can review. One physical property of acids is I see that hand over there. Yes, Carly. Great. The acids are sour. Acids react with carbonates, number 2, to produce. Kelton. Yes, carbon dioxide. Great answer. Number 3, an example of a polyprotic acid is. Okay, Abby. Very good. You could either say H2CO3 or you could say carbonic acid. You could also pick H3PO4 or H2SO4. And there's 3 of them that I had you memorize. Number 4, ammonia is considered to be a base because it, what? Now look at your chart of acid and base characteristics, and you're going to see that ammonia is considered to be a base because it is a proton receiver. Here's my chart, guys, okay? You should be studying this all week and memorize it. You need to know these things. And right over here, proton donor, proton receiver. So ammonia is a proton receiver even though it doesn't have hydronium or hydrogen. Number 5, an acid solution would have a pH of less than 7. Number 6, conductivity of an acid or a base in water is affected by all of the following set. Now, I stripped this off of a question that is obviously a multiple choice question, but the conductivity of an acid or base in water only occurs for strong acids and strong bases. So, I'm not sure how to word that, but write the word strong there. Number 7, acids produce what in order to conduct electricity in water? Hydronium ions. Again, 8, when acids react with metals, they produce hydrogen gas, or you can write H2. So these are right on this chart, guys. Number 8, when acids, number 9, an acidic solution contains more blank ions than hydroxide ions. Hydronium again. Number 10, in the blank model of acids and bases, acids are hydrogen ion donors and bases a hydrogen ion acceptor. It's Bronsted-Lowry. Okay, let me show you how it's written. Bronsted-Lowry. You need to know that guy's name. And he's the one that came up with proton donor, proton acceptor, which is the same, by the way, as hydrogen ion acceptor and hydrogen ion donor. Number 11, the conjugate base of a weak acid is strong. Those are always opposite. We talked about conjugate acids, conjugate bases. If one is strong, it's got the weak on the other side. If one is weak, it's got the strong on the other side. Number 12, what is the mathematical scale by which the concentration of hydronium ions is expressed? pH. And by the way, pH is small p, capital H. pH. Okay, always a small p and a capital H. No space in between. And when you write POH, same thing. Small p, capital OH. Remember that those two added up, always add up to 14. A base, number 13, that dissociates completely in water is known as a strong base. 14. The substance that produces hydronium ions when it dissolves in water is an acid. Number 15, blank is an acid that dissociates completely, a strong acid. 16, the combination of a water molecule and a hydrogen ion is a hydronium ion. Let's review how to spell that. Hydronium. And that's H3O+. plus. Okay? Hydronium. Number 17. A blank is a substance that produces hydroxide base. 18. An acid that ionizes only a slight degree, just a little bit, is a weak acid. 19. The reaction between an acid and base is a neutralization reaction. Number 20. A blank is a base that does not ionize to a very great extent, a weak base. 21. Why is acetic acid weaker than hydrochloric? Because it doesn't dissociate completely in water. 22. What is a strong acid? One that dissociates completely in water. Number 23. Why is it incorrect to say that all acids turn indicators pink? Because the only indicator that turns pink would be litmus paper. Okay, so litmus is an indicator, but not all indicators are litmus. Okay, remember we looked at all the different kinds of indicators: bromocresol blue, phenolphthalein, alizarin, yellow GG, all these really cool words. Okay, so there are lots of different indicators. They turn all kinds of different colors. But only litmus, or litmus is one of these specific ones that would turn pink if it was an acid. 24. Since methane contains hydrogen atoms, why is it not an acid? And the reason is that hydrogens in methane are not acidic hydrogens. Okay, AC. This is the adjective form of the word acid. So acidic hydrogens. And methane doesn't have any of them. Otherwise, they would be listed first. Remember, the acidic hydrogens are always listed first, like here is acetic acid. This one is acidic, and those ones are not. Okay? The acidic hydrogens are always listed first. So that's why they're monoprotic if there's one hydrogen in the front, diprotic if there's two hydrogens at the front, and triprotic if there's three hydrogens at the front. Number 25, give the formula for sodium hydroxide, NaOH, and identify as weak or strong. Strong. 26, write the formula for hydroiodic, HI. I always wave when I say that because I'm saying hi. And identify as weak or strong. It's a strong acid. And 27, you test several solutions and find that their pHs of 4.7, 10.8, 6.2, 1.6, 8.2, and 11.4. Which solution has the highest concentration of hydronium? Hydronium would be acid. So which one of these is the strongest acid? 1.6. It's the lowest pH. It's going to be the strongest acid. Which one's going to have the highest concentration of hydroxide ions? That would be the one that has the highest pH or the maximum amount of base. Okay, and that's going to be 11.4 on this list. Which solution is the closest to being neutral? Now, don't forget here, we have to compare this to 7. Neutral is 7.0. So we're looking at 7 minus 6.2, or 8.2 minus 7. This is a difference of 0.8. This is a difference of 1.2. So it looks like 6.2 is the one that's closest to neutral. You gotta do the math, just subtract them from 7 and see which one has the smallest absolute value. Okay, so that is that review sheet there. Oops, do that. Put this in. Okay, now this sheet here, we've got a bunch of writing on it. I'm going to see if I can drop another file in here real quick. Let's see. You're watching as I do this, so you guys know my file structure better than I, some of you. So I'm going to go to Acids and Bases Summary. Nice. Aha! I only need those two. This is so cool. This technology stuff I'm really getting into, but it's frustrating at times. So just, again, bear with me in the next couple weeks. Or here we go. Look at that. Here is my acids and bases properties, and here is my acids and bases. Okay. This chart here, you need to memorize it. Okay. And again, don't think it's, oh, I got 3, 4, 5, 6, 7, 8, 9, 16, 18 things to memorize. There's not 18 things to memorize. Let me mark it up for you. Okay. One more time. Let's grab a highlighter here. And maybe a nice big teal color. Look at these guys. You really don't need to memorize those. You should already know how to say those and how to write them. Anything in group 1, lithium, sodium, potassium, hydroxides. Only half of them hydroxide. Anything in group 2, magnesium, calcium, and barium. Hydroxides have 2 hydroxides. So I can give you the word, you write the formula. I give you the formula, you write the word. Okay? Next, we have these 4 acids. Strong acids over here in yellow. Those are the ones that have the word hydro in front of them. Hydrofluoric, hydrochloric, hydrodromic, hydroiodic. Okay, and then we got our other 2 strong acids, and let's pick a different color for them. Here's a cool color. Baby blue. Nitric. And sulfuric. Notice there's no hydro. No hydro in front of those. Only the 4 halogens have hydro in front of them. Okay, in the weak acids, you got 3 of them. And the easiest way to recognize them and name them is based on their pink. Oops, what's going on here? Pink polyatomic ions. Okay, so carbonate turns into carbonic acid. Acetate turns into acetic acid. And phosphate turns into phosphoric acid. Don't forget to put the word acid after all of those. And don't forget how to spell phosphoric. Please, Gordon Brewer. No, just kidding. I'm picking on you. And then we have the weak bases. And there's only 2 of them. And they're very closely related because we have ammonia and ammonium hydroxide. Ammonia, just by itself, NH3, and ammonium hydroxide, NH4OH, weak bases. Okay? So they're kind of like in 4 or 5 groups here. They should be easy enough to memorize if you've been working on them for a few weeks, which we have. Okay, the next thing that we need to look at is our chart here, and you definitely want to study this as well. Notice at the bottom of my chart, I've got some other terms from the chapter, which you don't have on yours, but that's okay. And so notice down here, I've got the word, oops. Right now, my picture on my screen is showing that I'm kind of behind that acid down there. So I don't know if you see that or not. It bothers me a little bit, but maybe I'm on top of your screen. So I'm just going to go through the check mark here a little bit. Bronsted Lowry. You don't have to know that. Ignore that. Acid anhydride, basic anhydride. You don't have to know that. Indicators, you need to know what those are. Log scale, pH and pOH. Neutralization for sure. Stop it. Neutralization for sure, and conjugate acid, conjugate base. I don't think we talked about titration, and I don't think it's on the test, so don't sweat it. And when I grade them, I'll double check. Okay. I'm not going to go through this chart anymore with you. We've done it probably 3 times already. If there's any questions, I'll be having a Zoom meeting on Thursday morning at 10 a.m. It's voluntary, but if you want to tune in, I'll send you a invite by way of email, I think, and you just click on the link. It'll bring you there. I think that's how it works. Still kind of new to this. And if you have any questions from anything, bring those questions on Thursday to ask me about them. And then make sure you get the test done before midnight on Friday. So, quick reminder, you owe me 3 things this week. Okay? Homework, page 513 and 551, 1 through 6, submitted through Google Classroom on the form that I gave you. Homework, this list of questions right here, which I also put in a Google form for you to fill out. So fill that out and submit it through Google Classroom. Both of those are 20 points. And then, guys, the test. And the test will be worth 100 points. And it's the same test that I gave the class on Wednesday of the 18th. So if you took it already and you like the score you got, you don't have to take it. If you didn't take it on the 18th, you have to take it before midnight this week. And that is on a program called Flexi Quiz. And Flexi Quiz has a time limit, so we have a 50-minute time limit. And just looking class, which is about the same amount of time we have in class. Everybody that took the quiz, the test on Wednesday, finished with plenty of time left over. So I don't think it's an incredibly long test. It's multiple choice, short answers, a little bit of matching. Any questions? Shoot me an email. Okay? Getting late here, so I gotta pack up. Have a great night. I finished this in about half an hour, 32 minutes and 49 seconds. Have a great day, whatever day it is that you're watching this. And be healthy, be safe.